Welcome to the simulation class. This is lab exercise 4. So for this problem, we're gonna build a model for an office of a state license bureau. And in this problem, we're gonna learn three things. First, how to create and use capacity sets. Second, you're gonna learn how to assign priorities in a queue. And the third objective is to understand how to create a non-stationary process, meaning that how to modify the arrival rates throughout the day. Okay, so let's read our problem description in order to understand the model. So basically in our office, we're getting two type of arrivals, two type of customers, individuals interested in purchasing new plates. So we have the interarrival time and the service time for these customers, and then there are a second type of customers that want to renew or apply for a new driver's license. We know the interarrival time and the processing time as well. So the office has two separate lines, one for each customer type, and the office has two clerks, has 5 clerks. But these clerks are separated in two different sets. So we know that there are two devoted to plates, which are Mary and Katie, and there are two resources devoted to licenses. So we have Sue and Jean, and the fifth resource, Neil, it's the team leader, and he's able to perform both services. So he will be kind of like in the middle of our queues. So he's able to assist both process. Okay, we're going to simulate this model for 8 hours, and there is an important note is that we're gonna by default queues are created using the first in first out rule. That means that if given that we have two queues, if we have customers in both queues and they want to assist Neil, so Neil is gonna be seized by the customer who has been waiting the longest. So if we leave the FIFO rule activated, so we're not gonna have any problem, because by default Arena is gonna assign to Neil the customer who has been waiting the longest. So one more thing in our problem description is that given that Neil is multi-talented, you would want to assign someone else to the next customer if you have the choice. So basically, Neil will be assigned if other resources are busy. But if, for example, for the plates process, for the new plates process, if Mary and Katie, if any of them are it's idle, so Neil won't be assigned. The only case in which Neil will be assigned, it's if Mary and Katie, for example, are busy and there is one more customer arriving asking for a new plate. So if Neil is idle, we are going to assign that new customer to Neil. But if the two resources, if any of these two resources, it's idle, then we're not going to use Neil. Okay, so let's build the model for this problem description. Basically, we want to analyze the average cycle time for both customers type. So let's go to Arena. So we have two types of customers. We need two different creates. For the first one, we're going to model the new plates customer arriving. Let's assign a name to the entity type. New plates, I'm going to call it. The interarrival time is an exponential distribution with parameters 6.8 minutes. Then we have a second create. This is for the driver's license. the entity type. Let's assign a name, driver's license. The interval time is an exponential distribution, and the parameter it's 8.7 minutes. Okay, so let's continue. We know that we have two different queues. So that means that we have two processes. So we're going to use the sys delay release logic. And for resources, we're not going to use the type resource. We need set. Why? Because remember that nil, it's we need to place nil in both processes, so we need to create a set. That's the only way to add nil to both processes. So let's create the first set. By default, the name is set1. Right now it's empty. And then we need to select the selection rule. So by default, it's cyclical. In the cyclical, Arena is going to try to seize in order the sets. So it's going to try to seize the resources in set 1, the first one, then the second one, then the third one. That's the cyclical. It's going to try to do the 1, 2, 3 sequence. But in this particular case, we're going to use the preferred order. Why? Because in the preferred order, we're going to try to seize the initial resources in our set and the resource that is located at the bottom of our set is saved just to be assigned in case that the two previous resources are busy. So why we're doing this? That's because remember that nil, in the problem description we had that nil is multi-talented, so we want to save nil and use nil just when it's required. So when it's required means we're going to use nil in the case where the other resources are busy. So let's use the preferred order logic. The processing time is a triangular distribution in minutes. And the parameters are 8.8, 13.7, and 15.2. So now let's modify our set. Please notice that right now it's empty because we haven't added the resources. So we know that for the first process, for the new plates, we have two resources initially, Mary and Katie. And Neil, which is the team leader, we're going to place it in the third row. Remember that the position of the resources is critical within the set, because given that we have assigned the preferred order logic, that means that for this particular set, Arena initially is going to try to seize Mary, but if she is busy, then Arena is going to try to seize Katie. And if these two resources are busy, then Arena is going to try to seize Neil. So that's the difference between the cyclical and the preferred order. Because in the cyclical logic, Arena is going to try to seize initially Mary, then Katie, and then Neil. For Arena, in the cyclical rule, it doesn't matter if Mary and Katie are busy or idle. It's gonna try to seize Neil in the third, because it's located in the third position. So it's gonna try to the cyclical rule is gonna try to seize using the 1, 2, 3 sequence. But the preferred order logic is gonna try to seize the first two resources initially, and then if these two resources are busy, then it's going to try to seize Neil. Okay, so we're done with the first process. Now for the second one, we need to apply the same logic, the sys delay release. and we're going to use sets, but we need a different set. So by default we get the set 1, so let's change from set 1 to set 2. It's not cyclical, it's preferred order. The delay type, it's a triangular distribution in minutes. 16.7, 20.5, 29.2. Now we need to add the members to set 2. Right now it's empty. So for set 2 we have Sue, Jean, and Neil. Okay. So far we have created the two processes, including the sets. So we're done with part A. So let's dispose our customers and let's run the model. Before we run, remember that we're going to run this model for 8 hours. So we need to go to the replication parameters, and the replication length will be 8 hours. Hours per day, 8. And the base time units, let's use minutes. Okay, so let's run our model, and now let's check the results. So the number out is 108 customers. And the total times, we have two values. For the driver license customers, it's 29.7, and for the new plates, it's 18.24. So let's go to our table. So the new plates customers, that's the 18.24 minutes. And for the driver's license customer, it's 29.7. So we're going to use these values for further comparison with part B, C, and D. So right now, it makes sense to have a higher value for the driver license customers, because if you check the parameters of the triangular distributions, those parameters are higher for this customer type. Okay, so now let's read part B. So for part B, the office is considering cross-training Katie so she can serve both customers type. Model this change and compare the average cycle time by customer. So basically now Katie, it's like Neil, so she's able to perform both activities. So in order to adapt our model to part B, so basically we know that Katie, it's located in the first set. So let's go to our sets. So she is in set 1, so we don't need to modify set 1. Basically, we need to add her in the second set. So let's play Katie, and then we have Neil. So we have added her in our second set. We don't need to change the process because the process is using the second set. So that's the only modification that we need for part B. So let's run the model again. The number out is 110. And let's check the processing times, the total times. Okay, for the total time for new plates is 19.04. So for new plate is 19.04. Please notice that it's increasing compared to part A. Why? That's basically because for part A, Katie was dedicated just to this type of customers, but now she's also assisting the other queue. So that's why we're increasing the utilization of Katie, affecting the processing time or the total time of the new plates customers. But let's check what's happening with the total time for the new customers for the driver license. For those customers, the total average time is 28.61 minutes. So please notice that it's decreasing compared to part A, which makes sense. Why? Because now in this second process, we're getting help from Katie. That's why the time is decreased by 1 minute. Okay, so now let's check part C. So the office is considering cross-training all of the agents so they can serve both customer types in a single queue. So let's modify this change, but there is one more information here, and is that we want to give higher priority to customers that are requesting a new plate. So we need this consideration for our queue. We want to prioritize the new plates customers. So let's go to Arena. So for part C, we need to merge these processes, and we're gonna get just a single process with a single queue, and we need priorities for that queue. So let's delete one process. So we need to create an attribute for the processing time, because we have a single process, but we have two different customers. So we need a couple of assigns here for the processing time. So I'm going to call it p-time. And for the new plates customer, it's a triangular 8.8, 13.7, and 15.2. We need a second assign, and we're going to assign the same attribute, the p-time. It's a triangular distribution. Parameter 16.7, 20.5, and 29.2. Okay. So for sets, we just need a single set to 1, but we need to add our 5 resources in set 1. So let's go to sets. We don't need set 2, so let's delete set 2. So for set 1, let's add Sue. Let's add Jean and Neil. So we have our 5 resources: Mary, Katie, Sue, Jean, and Neil. And for the process, remember that we have created the attribute p-time, so we need to change the delay type to an expression in minutes. We're going to use the p-time attribute. So finally, we need to modify the logic of our queue. So we go to the queue module. Please notice that the type of queue by default is first in, first out. So we're going to modify it, and there are different types. So these last two types, it's the lowest attribute value or the highest attribute value. We can use both. So basically what we're going to do is like we're going to create a new attribute. You can assign the name, yeah, let's call it queue time, queue priority. Let's call it queue priority. So using that attribute name, we're going to assign one value. We can use 1 or 0. So if we're using the highest attribute value, so if we assign the value of 1, that means that Arena is going to give more priority if the attribute is equal to 1, and less priority if the value is equal to 0. So if you want to do it the other way, then just use the lowest attribute value. So it's the same if you use the lowest or the highest. The only thing that changes is that instead of taking the max, it's going to take the mean. So you just need to be consistent. So in this particular case, let's use the highest attribute value. So the attribute name, let's create the name. I'm going to call it queue priority. So we're going to need this attribute in these assigns. And given that we're using the highest attribute value, remember that we want to give more priority to the new plates customer. So we need to assign a higher value to these customers in order to give higher priority in the queue. So let's go to assign 1 and let's create the attribute. It's queue priority. So the value, I'm saying 1, but if you want to use 10, that's fine. The important thing is that this value has to be higher to the value assigned to the other type of customer. So I'm using 1, the value of 1. So for this customer, the value needs to be lower. Queue priority. So I'm going to use 0. Okay. So let's run our model. And let's check the results. So now the processing time, the total times are lower. So for new plates, it's 14.57. So please note that time is decreasing. And for the driver's license customers, the total time is 24.18. So why the processing times are getting, the total times are getting lower? That's basically because remember that now we have just a single queue. So when we have a single queue, we are increasing the utilization of our resources. So that's why now the total times are getting lower. So for part D, the customer arrival pattern for individuals interested in purchasing new plates varies over the day. When a parameter varies, so we start talking of a non-stationary process. That means that the arrival rate is not the same throughout the day. So if you check in this table, we have 3 different parameters. So the first 4 hours, the arrival rate is 9 customers per hour. Then from 4 to 6, the arrival rate is 15 customers per hour. And finally, the last 2 hours, the arrival rate is 8 customers per hour. So my initial question, so do you think that are we getting more customers now, or are we getting less customers compared to part A? So I want to give you 5 minutes, 1 minute to think about it. Okay, So here, in fact, we're getting more customers. Why? Because the initial inter-arrival time, it's 6.8 minutes. That's the initial inter-arrival time. So now, when we check the arrivals, this is the number of arrivals, it's not the inter-arrival time. If you want to find the inter-arrival time per hour, inter-arrival time during these 4 hours, so you need to divide 16 minutes over these 9 arrivals. So if you do that, you will get 6.66 minutes. That means that the inter-arrival time is lower than our initial 6.8 minutes, meaning that we're getting more customers. And especially from 4 to 6, please notice that the arrival rate is 15. So that means that the inter-arrival time is 4 minutes. So it's way lower than our initial value, meaning that we're getting more customers. So we're expecting to have a higher number of customers using this non-stationary process. So let's go to Arena and let's add these new arrivals of 9, 15, and 8. Okay, so now for the new plates arrival, we're not going to use the same lambda or the same 1 over lambda. We need to change it, so we need the schedule to schedule the arrival. So in previous models, we have used the schedule just for the capacity. So now we're going to use a schedule for the arrivals. So the name of the schedule is schedule 1 by default. If you want to change it, that's up to you. So the type of schedule is arrival. Yeah, in the past we used the capacity one, but let's leave it in arrival. Time units, let's use hours because the parameters are per hour. The maximum arrival rate in our table is 15, so let's change the maximum from 10 to 15. So our initial arrival rate is 9 during the first 4 hours. Then it increases up to 15 for 2 hours. And the last 2 hours, the arrival rate is 7. It's 8. Okay. So let's run our model and let's check the average total time. So the first modification that you can notice is the number out for part A, B, and C. The number out, the total number out was between 100A and 110, and now please notice that the number is increasing. That's basically because we're getting more customers now in our system. So our system is more crowded. So if we go to the total processing time, the total cycle time. So for the new plates, it's 14.65. And for the driver's license, it's 26.7. So please notice that the numbers are increasing compared to part C. That's basically because the system is more crowded now. So the waiting time is getting higher. So that's why these numbers are a little bit higher compared to part C. Okay, so that's everything for today. So we hope that you learn how to use the capacity sets, the resource sets, how to model non-stationary process, and how to assign priorities. So I will see you in our